boys and girls, it's your main math man, Miss Shank, coming to you live from Alameda International High School. And in this video, we're going to be working on some solving equations. And for the first couple ones, we're going to be just doing some one-step equations. And so that means this. You're just going to be doing an inverse operation one time to solve for your variable x. So for example, in number one, it has 6 is equal to x plus 2. So you're trying to figure out what value plus 2 is equal to 6. And so kind of like unwrapping a present, you want to undo what was already done. So if it gives you a plus 2, that means you want to subtract 2. And whatever you do to one side, you must do to the other. So I have subtract 2 from both sides. On the right side, my 2's cancel out. And so I have just x. And then on the left side, I have 6 minus 2, which is just 4. Again, you can always plug in your value for your variable to check. So for example, I can say 4 plus 2 is equal to 6, so I know that x equals 4 is the true answer. And number two, it reads like this. It has 3 is equal to 1 plus x. You can also model out your equation using that key provided, but we want to say this. So I have a positive 1. Only way to get rid of it is adding the opposite. So I want to have a negative 1 to both sides. On the right side, my x comes down, and on the left side, I'm just left with 2. Moving on to number 3. It has 5 is equal to x minus 2. Make sure you can draw your railroad tracks. I'm trying to show 2 different sides of the equation. So we always want to make sure that it is balanced. So I want to make sure that I have x minus 2. What's the opposite? Well, it's going to be a positive 2. So I want to add 2 to both sides. On the right side, the x comes down. And on the left side, we have 5 plus 2 is just going to be 7. So again, make sure you're very careful on those positive and negative values. Use those integer counters to your benefit. In number 4, it has 7 is equal to negative 3 plus x. So the opposite of a negative 3 is going to be a positive 3. So I add 3 to both sides. The x comes down. And I have 7 plus 3, which is just 10. So that was just some simple addition and subtraction problems. Again, make sure you can pause, rewind at a point in time. In number 5 and in number 6, make sure you're seeing carefully, since those variables are attached to the value. That just means multiply. So if it gives you multiplication, you want to divide. So I'm going to divide both sides by the coefficient, which is that value that's attached to the variable. So I'm going to divide both sides by 8. On the left side, 40 divided by 8 is just 5. And then on the right side, make sure you're not saying this is 0, because 8 divided by 8 is 1. So I'm going to have just x. So I'm going to say 5 is equal to x. And you can always plug in to check. So I'm saying 8 times 5 is going to be equal to 40. On the number 6, I have 28 is equal to negative 4 times x. Always divide by the coefficient, so always make sure you're saying, hey, since this is a negative 4, I need to divide by that value. So I have divide both sides by negative 4. On the right side, I just have x. And on the left side, since these are different signs, again, use those integer rules for yourself. So different signs means my answer is going to be negative. So 28 divided by 4 is 7. So I'm going to say for that one, x equals negative 7. On back, similar idea, but we're saying now if you're given division, you want to do the inverse, which is multiply. So I'm going to take and say, all right, I have 8 is equal to x over 2. So that means I can take and multiply both sides by 2. So I have times 2 to both sides. On the right side, the 2's cancel out, so I'm just left with x. And on the left side, I have 2 times 8, which is 16. And then in number 8, similar idea, make sure you just multiply both sides by that same value. So I have both sides times negative 3. The reason why we're doing that is we're trying to get that x by itself. We're trying to isolate that variable. So I have x on the right and on the left, different signs means negative. So I have 3 times 21, or sorry, 3 times 7 is 21. So I'm going to say x is going to be equal to negative 21. So those are 1 through 8, those are all one-step equations. For number 9 and number 10, however, those are 2-step equations. That means you're going to have 2 inverse operations to get your variable. Similar setup though, make sure you can have 2 sides of your equation. I'm trying to get that variable by itself. That means I have to get all the constants to the other side. In order to do that, I just have to add the opposite. So the opposite of a positive 1 is a negative 1. So I'm going to subtract both sides by 1. On the right side, I'm just left with 3x. On the left side, or excuse me, on the right side I have 3x. On the left side I have 6. Last step to get your value, just multiply by the inverse. So I'm going to say, all right, well, what's the multiplicative inverse of 3x? It's just 1/3, which is the same as dividing by 3. So I have x is going to be equal to 6 divided by 3, which is 2. Again, make sure you can do that check step for yourself. So we're going to say check. In order to do that, I let x equal 2, and I plug it back into my original equation. So I'm going to say, okay, wherever I have an x, I now have a 2. So I'm saying is 7, so I'm trying to figure out is 7 equal to, and I have 3 times 2 plus 1. Again, you're just trying to simplify and make sure both sides are equal. So I have 3 times 2 is 6, and plus 1. And I'm going to say that since 7 is equal to 7, be very mindful of what your answer is. I'm still saying that x is equal to 2, but since both sides are equal to 7, I know that x equals 2 for this problem. Similar setup for number 10, very last one. Have your 2 sides of your equation. I have a negative 4, which means I have to add the opposite, which is positive 4. So add 4 to both sides. On the right side, I have just 2x. On the left side, 14 plus 4 is going to be 18. Last step, divide by the coefficient, so divide both sides by 2. And I have x is equal to 9. Again, do that check step for yourself. So I let x equal 9. Plug it back into your original equation. So I'm asking is 14 equal to 2 times 9 minus 4. So I have 2 times 9, which is 18. Bring down the rest of the equation. And then I'm saying, all right, 18 minus 4 is 14, which is equal to 14. So I know this is a balanced equation. So again, that just means that since my 2 sides of the equation are the same, that means that my answer is still 9. Again, feel free to ask any questions at any point in time, and as always, super slam that subscribe button.